Hello everyone, my name is Vadim. I'm one of the core developers of Robonomics network project. And today's topic is vertical solutions on Robonomics. I will split my talk into three sections. First, we will speak about theoretical stuff about what Robonomics is, what functions it has, how we can utilize it. Then I will show you a few of the hardware that we design and produce by our team. And then I will speak a bit about a real ongoing use case that we implement on Cyprus and our plans in the future. So let's get started. First, what the Robonomics? The Robonomics is a decentralized platform to manage your IoT devices and robots. We started to work on Ethereum network back to 2017. Then, after seeing or facing a few limitations of Ethereum network, we came up to the conclusion that we need to look at the other options, at the other ecosystems, and that in 2020 we released our, let's say, a Polkadot version of Robonomics. So now we have two versions of Robonomics. Most of the talk will be dedicated to the Polkadot version that comes with IoT services and stuff. We are a fully open source project. As you can see, there are many contributors. The repositories are quite active. The first two repositories, Robonomics itself and Robonomics.app, is a Robonomics core functionality. It's a collator, it's a node that runs the Robonomics. The second one is a DIPP. It's an application to interact with Robonomics functions. The rest of the links are dedicated to the most mature project built on top of Robonomics. But before we go to the projects and the use cases, I would like to answer one question. Why the hell do we need to control IoT and robots in a blockchain, in a Web3 way? I'm pretty sure everybody is aware that there is a high demand of connecting all of the smart devices, all of the IoT devices to the internet, to send data, to send command backs, to get the analytics, etc. And there are great corporate, like AWS previously mentioned, or Azure from Microsoft. They already provide you functions to connect all the devices, to send telemetry, to see all the measurements, and to see what type of commands we can send back. Obviously, there are some concerns about using these corporate solutions. One of them is you're really tied up to using this service. If they decide to change your policy, you need to obey. If they decide to change anything, you just obey. It's really easy to start implementing such solutions on top of those cloud providers. But then after a while, you would like to grow more, you need to pay more. So using Web3 technologies, at the very least, is much, much cheaper than using those cloud providers. The other reason that should be the first one is the privacy, the security. And when you deal with AWS or any other cloud providers, they create a key for you, not you create a key for yourself. And for me personally, it's always fun to connect such things and play around with the Web3 and stuff. So in Robonomics, we came up with the approach of using blockchain almost in the same way as you would use the cloud providers. We have a subscription-based model. In terms of technical, it's like you purchase a token, you activate it, and you have some amount of, let's say, gas or computational power for a month, and you can utilize Robonomics function without even paying a single fee. What functions? One of them is obviously to send data to the blockchain. If you need to send a lot of data to the blockchain, please use IPFS and just store the IPFS hash in the blockchain. But anyway, there are like 500 bytes you can store as the raw data in the Robonomics. Then we have a launch command. Launch is dedicated to create a special event in the blockchain, and when the device is connected to the blockchain and listens to the events, it will see the event, it will see the parameters, it will see the command, and we'll try to execute it at least. We have a special model for creating the digital twin, a digital shadow. You can replicate your system in the digital way. Now, since we're in a DePIN day, I would like to briefly discuss the most straightforward and the most obvious way of building DePIN project, but still there are some notes I would like to discuss. First layer of this DePIN pie is the physical part. It's just a regular device, and on this layer we just think of what actual functions it would provide, what it will do, and here we will think of just, okay, it will connect over Wi-Fi or over Zigbee or any other physical protocol that we can think of. Then there should be a connectivity layer. This layer must consist of a few nodes at least. It's not meant to be just one single server that collects all the data from any device and sends it to the blockchain. There is no reason to have a blockchain after a single server because you have a bottleneck. It's not a DePIN project. It's just a project. Just forget about blockchain and use the project itself. In the DePIN project, it should be a few nodes that not necessarily speak to each other, but at least they need to provide this kind of decentralization. The last layer is Web3 cloud. It's just a regular decentralized network as Robonomics is. So now let's have a look at the real use cases, and one of them is it actually showed the potential of the DePIN. We call it altruist. It's an air quality control sensor which measures a few parameters like the amount of particles in the air, the temperature, the humidity. But the most interesting part is this sensor connects to one of the connectivity servers, not just one server, but one of them. And sometimes from time to time, like every hour, every 2 hours, the servers, they just close the connections with all of the sensors, and those sensors need to find a way to connect to its server again. It's needed to reorganize sensors from time to time. Obviously, after connectivity server, all the data goes to the blockchain and goes in the peer-to-peer way to be displayed on your map or in your application. The second device that we design and produce, we started to investigate with the RISC-V. The idea is pretty simple. Since all of the stack is open source, then why don't we use ARM-based CPUs or Intel-based CPUs? RISC-V is an open source architecture of CPU. So we decided that next year we will create a home server that will be fully open source from the bottom, from the hardware part up until the network itself. And the Hikikomori, it's a new project. It's basically Tamagotchi, but instead of interacting with the Tamagotchi itself, you connect it to the smart home system of yours, and you interact with your smart home system, you push buttons, you call automations or scripts, and this Tamagotchi gets hyper when it sees such interactions in the smart home. So the general idea of those devices is we all love to use smart devices, but every single time you purchase a device, it asks you to install a specific application and to connect it to your Wi-Fi, to provide you an email address. And these devices, they send immediately all of the data somewhere. We don't like it. We like using smart Hoover. We like using a smart air refresher or whatever, or a camera. But we don't like that our data is streamed somewhere without our knowledge. So for the next year, our team has decided that we will produce a few devices for the end users that will be cloudless, they will not be connected to any central server until you wish to. And to conclude my presentation, I would like to speak a few words about a real use case that is happening right now on Cyprus. And let me introduce myself again. I'm Vadim, and I'm co-founder of Pinout Limited Company, which is based on Cyprus, and it provides smart home solutions without any cloud providers. So basically what we do, we use wireless devices. We use a home server, which is basically a Raspberry Pi or a computer that you have. We install Home Assistant. It's a great open source application. It's great open source software that allows you to interact and manage all of your smart devices, whether they connected over Wi-Fi or Zigbee or whatever protocol you use. You can create automations, you can create schedules, and you can operate with all of the devices with this Home Assistant help. And all the data stays in your apartment, in your house. What we did is we created a Robonomics integration that allows you to interact with your smart home in a Web3 way. You can open a dashboard, a DAPP of this smart home solution, and interact with your smart home solution. Smart home, we send in peer-to-peer messages, or like creating a list of users that have an access to your home. I think I was kind of fast, so that's basically it. I have time for a few questions. Thank you.
Great, thank you. Questions for Vadim? Any questions? All right. That means everyone understands it completely. Oh, we got a question. Go.
Great presentation. So for like, I want to know about your risk architecture a little bit more deeply.
All right. So we started to investigate on RISC-V this year, and what we did, we purchased one of the most popular single-board computer on RISC-V, and we installed all the necessary software from operating system, then Home Assistant, Robonomics integration on it, and it was quite challenging, to be honest. So RISC-V is not fully supported yet by a lot of software, so we had to compile a bunch of stuff ourselves on the board, basically. Our plans is to create a computer, basically a server, this small one, with the pre-image of every software you would need, so you would not suffer during the installation process.
That's great. So like you showed your GitHub profile. So on that, I'd want to know like, okay, I'll ask you more about that later.
No problem, okay.
Thank you. Do we have any other questions? Oh, yes, another one.
Hi. Can you do video distribution from the home in a kind of peer-to-peer fashion?
Not in a like live streaming way, but we can open a channel so you can get an access directly to your camera from your home server, for example. Or we have a special dedicated service that can track movements, for example. It takes like a 10-second video and store it in a blockchain so you can retrieve it later at your convenience.
I think that is
Thank you,
it. Well,
everyone.
listen, round of applause. Thank you very much.